Good morning, boys and girls. Today we got a quick little lesson on taking the derivative of natural logs, okay? Natural log differentiation. Just really this lesson's kind of quick and a short one. It's just some more derivatives that you're going to have to memorize, unfortunately, but I don't think they're that hard. They're not too bad to do. The derivative of ln of x is 1 over x. Okay? And again, you're just going to want to memorize that. Because it's another case where you could have a bunch of stuff on the inside, we're going to have to try to apply chain rule. Another way to look at this is if u is some function, the derivative of ln of u is 1 over u times derivative of the inside, u prime. Or you'll frequently see this as u prime over u. However, I always stick with this thought right here. Okay, if I can take the derivative log of ln, it's 1 over that thing times the derivative of the inside, applying chain rule. Okay, so just have that down and memorized. And I guess being mathematically correct here too, I almost forgot to add, but I should add that in this case, the qualifier would be that u has to be greater than or equal to 0. That way we can actually take the natural log of it. But I should probably add that little piece there, just as a qualifier. All right. Our next question then becomes, how do I take the log then of, something that's not a natural log, that's just a regular log? So if I've got like log base b of u, where b is any base and u could be anything on the inside. To do this, we do our little formula that's 1 over u ln of b times u prime. Okay. Now, I don't know if you were watching my eyes there as I did this one, but I did have to look over to the side to double check myself. That first one, ln of u, taking the derivative of natural log, you want to have down and memorize. You got to have that one, no question. This one here, I think you should know that this exists, and we should know how to use it, and we're going to practice with it a little bit today, but this is not like the most common thing that we are going to see. Okay. I think occasionally, like maybe once in all the stuff I've looked at once or maybe twice, I've seen it pop up on the AP test, but the other one for sure will appear a lot. This one, again, kind of like our trig identities, I think we just want to know it's out there, that we can use it, but I wouldn't worry a ton about this one here. Again, I would also need a qualifier on this one that u has to be greater than 0. Again, we're being mathematically correct. Okay, last derivative we're going to add today is the derivative of b to the x, some number to the x power, where x is now in the exponent, 3 to the x, 5 to the x, something like that. When we do this, the derivative of b to the x is b to the x times ln of the base, whatever that is. Okay. And again, this is just if it was terms of x. If I did this, again, in terms of u, okay, where again, that could be some inside function, this would be b to the u ln of b times u prime for the chain rule. Okay, so these are the three main derivatives we're picking up today. That first one, the most important one, the derivative ln of x is 1 over x. The second most important one, I would say, is this one here. I've seen this one pop up. Again, not all the time, but this one does pop up fairly frequently. So we should be able to take the derivative of b to the x or b to the u. And then the third one, which is we should know it's out there and be able to use it, was that log base b of u. Okay, being able to take the derivative of that. All right, let's do just a quick couple of problems of showing how to use these as for derivatives, and then we're moving on. We're done for today. Okay, so here's our first problem here. We want to take the derivative of ln of x squared. So we said to do this, if I took the derivative, this is 1 over u, so 1 over x squared, times u prime. So take the derivative of the inside, doing my chain rule, 2x. Or we get 2x over x squared. Or I can reduce that, and so the derivative of this function would be just 2 over x. Easy peasy lemon squeezy. Okay, next problem here. We want to take the derivative of x squared plus 1 times ln of x. In this case, we hopefully are noticing that this is a product, right? We have two things multiplying together, so I'm going to have to use the product rule. So if I go and start taking the derivative of this, I'm going to take the derivative of the first times the second plus the first times the derivative of the second. So we're just going to be applying this rule into other places. Again, I want to go and kind of tighten this up now a little bit. 2x ln x plus x squared plus 1 over x. And now again, I've technically taken the derivative. I would go check my answers again to make sure that it's matched, or see if I got to do some algebra work to make my answer match the book. And giving the answer a look in the back of the book, we were pretty much right there. The only thing they did was they switched these two terms. Not sure why. So they had x squared plus 1 over x plus 2x ln x. Either of those, I would say, is the same thing. We are good to go. Nailed it. All right, moving on to the next one. Okay, now we want to take the derivative of 5 times 4 to the x. So again, a little bit different story now that we got x in the exponent. So a couple reminders here when we go to take the derivative. Notate it. When you have a coefficient, again, 5 is just a coefficient, right? Times 4. I mean, technically they're multiplying, and again, I guess you could use product rule to do this, but you don't really have to, and I wouldn't. You're making things harder than you have to if you do that. But that 5 is just a coefficient, so I can ignore the coefficient, and this coefficient can just hang out in front times whatever my derivative is. So now I just need to take the derivative of 4 to the x. So the derivative of 4 to the x is 4 to the x ln of the base. So ln of 4. And then now I could just, put this stuff all together. I don't know. I think you might see this as 5 ln 4 times 4 to the x. That seems weird still too. Maybe the right order might be 5 times 4 to the x ln 4. I don't know. Let's see which way the book wrote this here. Okay, looking at the book answer, they did have this answer right here. Y prime is 5 times 4 to the x ln 4. And again, it doesn't matter. Those are all the same things, just different orders. Just as a general note point, we generally like things like square roots and ln's at the end, so we don't get confused what's inside the ln and what's outside the ln. So that's why I kind of rewrote it this way. And we tend to, oh look, that was what I had up here too. Boom. I don't know. So both of those are good, either way. All right. One last problem, and then we're done. Quick video today. You gotta love that. All right, last one, just so we get a little practice with this kind of a derivative with a log base 3, right? So we said to do this derivative, y prime is going to still start out like with our 1 over u. That's what we do with ln, so 1 over x squared minus 1. But then we also have to multiply by ln of the base, so in this case ln of 3. And then using our chain rule, I need to multiply by the derivative of the inside, so multiply by 2x. And then as I was just doing this, I noticed I wanted to ignore that coefficient as I was doing this, but I can't ignore putting it in my answer, so I'm going to go ahead and throw that 4 back up on top of this. Okay, 4 times this stuff would be 4 on the top of that. And now I can simplify this. Y prime would be, maybe 8x over x squared minus 1 times ln of 3. All right. And checking my answer. Ooh. Got to look in the back of the book. All right, checking my answer. That's exactly what they have in the back of the book. So that's it, boys and girls. Good luck today, and I'll see you again real soon.